Can you hear me? Really? It is not available for me. I don't know. I think that is public. Comments are disable. Okay. Hello, hello. It is not available for me. I don't know. I think that is public. Comments are disable. Okay. Let me try that switch. Hello, hello. It is not available for me. I think that is public. Comments are disable. Okay. Let me try that switch. Hello, hello. It is not available for me. I think that is public. Comments are. Okay. Now let's do this. Hmm. Now let me clear this one because that was not a correct answer, but we can obviously go through the approach. Um, so I have already solved one of the coding questions in this, I don't know, this shuffle the array lead code. Okay, let me show you what this is. So, okay, go back. Yes, so in the quest mode, it showed me data structure and algorithms, and it says there are 35 problems, and out of which it shows you the path. So I was thinking of doing this. Um, so it will have like two parts. One where I will be covering the AI piece. Second is the coding. Uh, that is where I'll be covering data structure and algorithms, as well as a few of the developments regarding the Fast API or how we will be using the applications for or how we use LLM models or any Gen AI using Fast API. So more or less today we are doing this coding. So here is the array question. I did one of them. Um, why is it not opening? Right. Okay. So I can go back and show you. So this was a very simple question. And on the left side, you can see the question. On the right side or in the middle, I can code and write the solution. On the extreme right, I'll be just doodling how the things are and what my understanding is for the question. So, yeah. Um, so here we go. Let me just select. I think white should be fine. Yeah, that should be fine. Okay. So the first question was regarding concatenating or concatenation of array. So basically, we were given a nums array of length, whatever, n, and we are asked to create an array called ans uh, and its length will be 2n. And what it will do is, let me for some reason. Okay. Mm. So ANS will have the length 2n, and what it will require is, or the logic is, basically, let's say ANS is of length 2n. So let's say this is the nth, and this is n elements, and nums is of length n. So let's say it's 1, 2, 3. Then what we need to do is we just need to put um, these elements one after another. So basically, we'll cover first all of the n elements from nums, and then again we need to cover it again. So 1, 2, 3 again. So that should cover it twice. And yeah, that would this is the answer we need to return. So the basic logic what I found was we just add those two or just concatenate in Python. So I'll be doing all of the coding in Python because that's the main language that we'll be using and is required for the AI. And so basically nums uh, will be concatenated into the ANS array, and that will be returned. We could directly return nums plus nums or nums into 2. So that will also return the same answer. So that was the first question. I'll just sum it again just to show you it's working. Yep. Uh, and I think it shows 100%, but because other coding languages have um, you do need to add a lot more code for that. So it might take a long time. But again, okay, yeah, regarding that and memory, so Python generally takes more memory, so no issues there. Um, yeah, regarding the time complexity, so that would be big O of 2n, that is big O of n. So basically, we'll go through each of the element once, and that would cover the time complexity. Space complexity, we would be requiring like the 2n space. What we can do is we can add or just concatenate it on the nums itself, but that would also require the log of, oh sorry, big O of n. So basically, it will be same. Um, So yeah, that is the answer for this one. And let's go to the problem two. Okay, so this one is a good, easy problem where we need to shuffle the array. So, so this one I haven't tried. I haven't run it. I thought, why not stream everything? So, uh, like this is the shuffling problem or shuffle the array. And here, let me check out. Yeah. Okay. I think that is good enough volume. Let me increase it. Hopefully, it is streaming well. I have no idea. Well, let's get back to the problem. So we have been given an array nums again, and it contains uh, 2n elements, and those elements are x1, y, sorry, x1, x2, x3 till xn, and then so there is not a boundary there, but we can assume it 1, 2 till yn. Okay, and what they want is to output it in a manner that it returns in the format of x1 taking one element from here, one element from here, and x2 taking one element from here, one element from here. Something like del xn, yn. And important thing to note here is they have not mentioned it, but when you see the problem, you can see that it is like n is the value, or 2n generally means like we are splitting it in between. So the array is split in between, and then we are taking the elements. And that is what I can see from all of these problems. Um, well, though they have not mentioned it here, I am considering it as such. We can check for if it works or not later, but that's the assumption. So, what we can do here. So n is generally in the middle. So we'll be taking the first example as reference. So n is equals to 3 here, and they have the array 2, 5, 1, 3, 4, 7. Okay. Um, don't mind my handwriting. So what we need to do is we can have one pointer here, I, and one pointer here, j, and we can traverse it for n. So what will happen? We can just append here in the result array. Let me clear it out. Not like that. Append, and here is the result. Okay, so basically we'll append I and then we'll append j, then move the pointer by 1 unit. So I will be moved, j will be moved. Then we will append I again and j again. And then again we'll move I and j. And that is our answer. So that should work. Let's code it out. So here we have um, for I in range of n, what we'll do, we have two pointers, so I and j, so let's put it as ITR. So we have that discrimination between I and j, or the main loop, and the the individual pointers. So I, we are positioning at 0, and j, we are positioning at I plus n. So basically that would be on in the middle when I is at 0. So so we are iterating this, and what we want is the result. So we will have it here. So result array is like that, and we can append it. So result itr I. Okay. So what we can do is we can just place it like like this, where we have the result all values set to 0, and we will be updating those values instead of appending it. Um, we can append it as well, but let's do it this way first. And then what we will do is we will have nums at I, and we will have, sorry, just copy this, paste it, and I think I'm doing something wrong. So basically in the result, we have this pointer. Okay, so what we should call that? K maybe. Okay, so let K equals to 0, and here nums of I and nums of j. So K plus 1. Okay, and then K would be incremented by 2 because we are filling I and j, and I will be incremented by 1 and j will be incremented by 1. But the problem is we need to move this outside because these value will be else updated every time it comes inside the loop. So yeah, so this is and we should just return this result. But I would like to print this as well, so we have that understanding. Let's run it. Okay, all of them are wrong. What happened? Um, mm, so we are getting 2, 2, 5, 5, 1, 1. Okay. J is equals to I plus n. N is 3. So that would mean, okay, 2, 5, 1. So result, oh, here it should be J. Let's run it again. Yes. Okay. That seems to be working fine. Let's remove this and submit it. It would, yes, that works fine. But what I want is to kind of optimize it. Sorry. Because we are using like 3 variables. I mean, that is fine. The thing is, this could be done in a single go from my assumption. So let's remove all this and let's consider it here. Okay. So we have 2, 5, 1, 3, 4, and 7. Sorry, it just doesn't work now. Okay, and this is the nums array, right? So instead of using like 3 variables, let's have I here, and we know this location is like n steps ahead, so we don't need like I and j. Um, and we are iterating through the results, so let's do that. Um, so here also, let's say it's I. So we will be putting 2 and here I plus n, or basically here I plus n, and that should be 3, but I hasn't been incremented, but here we need to update it. So instead of updating the indexes, we can append it. I think append is that the function, but let's see. I think that should work. Results dot append. Okay, so nums of I, and here we would append nums of I plus n. Right. So that should do, and also we need to just keep it empty. Um, and this is I. Okay, let's try it out. Right. So it seems to be working fine. Um, so we just removed multiple variables. I don't know about the performance piece, but um, more or less it doesn't matter in a long run. But let's do that. So this is updated, and now let's talk about the time complexity. Time complexity is O of n because we are considering, let's say this is n because the length was 2n. Anyways, we would have to iterate it to the half of the array length, and that would come as O of n. And obviously, we would need space-wise O of n or 2n, but that would come as n. How about updating the space itself? Can we do that? Instead of taking extra space, can we do that piece? Okay. So let's consider 2, 5, 1, 3, 4, 7. And this is where we need to add 2 and 1. Hmm. Sorry, 2 and 3, not 1. Um, so the problem is, where would 5 go? We can move it to that position. Basically, okay, if I do that, um, 1, 5, well, it won't be the place and it won't be the place. Huh, if we see that, no, 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 no. I think we need a better example. Let's do 1, 2, 3, 4, 4, 3, 2, 1. Okay. Um, and it is here, right? So that would be 1 and 4. So if we are changing this here, so 1, 4, so it became 2, right? And now we need this and this, but that's not correct because we actually needed 2. Hmm, I think that might become an issue. Uh, so I think that should do. What is the constraint? So n is less than 500 to n. Okay, that's fine. But let's go for the solution. See what we have. So space is O of n. Really? Okay. Okay. So bit manipulation is something that I didn't know. I mean, I know it exists, but I have no intuition for this. Okay. Some bit manipulation knowledge will be helpful in understanding this algorithm, and this algorithm uses bitwise and or left shift, right shift, binary representation of numbers. And this is an in-place algorithm relies on the constraint of 10 to the power less than 3. Okay, This means the largest possible number is 1000. Okay. The binary representation of 1000 is this. If we count the number in bits, we got 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Because the largest possible number only uses 10 bits, we can fit the two numbers into a 32-bit representation. That's correct. This means we can store pair of number in one binary representation without fear of overwriting the number. Store pair of number in a binary representation, that is true. As shown in the description, the problem, the array is in the format this. This algorithm will use two loops. Loop 1 will group the numbers into pairs x1, y1. Okay, so we'll be selecting, and by storing both numbers xn and yn in one. Okay, loop 2 will then place these pairs in their final position. Okay, how do we store two numbers in a binary representation? We will use two pointer I and j. I will traverse from n to 0, and j will traverse backwards from end of the array to n. I think traverse backward from end of array. Okay, so basically end of let's do this only. I'm putting this in green so that I can just go through and remember. Okay, and our example was 1, 2, 3, 4, 4, 3, 1. 1, 2, 3, 4, 4, 3, 2, 1. And this is the nth place. So basically, it needs to say that let's cover 1 here, I, and j from here to here. Right. Okay. Yeah. Because nums j store both nums I and j in nums j is already storing its number. We do not need to add it. Instead, we need to left shift this number over 10 bits to make room to add another second number. Okay, we need to shift it over by 10 bits because the largest possible number is right. Okay, so this becomes nums I, and this becomes nums j, and we are storing both in nums j. And how we are doing it, because every number represents 10 bits. So we, or the maximum capacity was 10 to the power 3, that was 1000, which could be represented in 10 bits, and we have 32 bits of storage. So what we'll be doing is taking 10 bits here and 10 bits here. So what we are doing, we are putting nums j here. Okay. So we are just moving, we shift it over by 10 bits because the larger position. Okay. So that's how the shifting is done. I think that also. To add num I we can use bit or nums I with nums j. Okay, so I think this becomes empty or zero. So we are just adding those nums j is equals or bit or with nums I. Okay. Mm, when using the following input, loop 1 will look like the example below. Okay. Right. I mm, okay. Do we have a simple logic on this? Ah, so this will shuffle the variable. This function will have been used. Internal. Um, you said that was in Python. Now you just even odd. What is the time complexity? Uh, yes, it sounds is a better approach. Well, that's what I did. Come on, guys. Iterate item in one loop, return result. Fancy way, but it's still doing the same. I don't know why people do complex things. Uh-huh. Where is that JavaScript वाला बंदा? Um, I don't think this is what I want. I think this is interesting. Um, but on the same time, I'm feeling just so lazy to read through this. Okay. Can be found the binary representation does both get both numbers from nums j and update nums I and nums I plus 1. Increment I by 2 to place the next pair. Increment j by 1 to get the number for the next 2 points. Um, okay. What I'm not getting here is ये मैं 10 to the power 3 का कहाँ बोला था बे तो ऐसे भी okay the whole thing the whole thing nahi hai. It is a given value. Okay, okay. So what it is doing is it is trying to capture those values. Okay, let me get that. So basically, 1, 2, 3, 4, 4, 3, 2, 1. Okay. So it is saying this half should have value or could store values for both. Okay. Um, let's say this half we are saying sec. This is first. Okay. This is second half. This is first half. Okay. So what we are saying is to store all this information from the second and from the first into the second. Okay. So it will take this much of space of n numbers or n length of the array, and it will store both. Now what happens is we can take elements from this and put it here. And we are taking this and this and putting it at the last. Why not take it from that? I don't know why it did it like this, but huh. We can do is 1, 4, put it together, and then 2 and 3, put it together, and 3 and 2, put it together, and 4 and 1, put it together. Okay, so this is how we are representing it. Now, what we will do is we will take this item, expand it here, and this will be empty now. So basically, this will show it as 1, 4. Take this item, it will be empty. So 2 and 3. This item, 3, 2. This item, 4 and 1. Right. I think I got the gist of it. It is just how to represent the numbers. Hmm. Hmm. So you're saying what we can do is it is shifting by bits. Why not just multiply it? Would it be crossing any limits for that? 1000. Well, I don't think in Python it will cross any limit. So my logic is just to multiply it with 1000 and then just add that number. And once that's done, we can just move. What we can do is just divide by 1000, can move the quotient somewhere and the remainder somewhere. Easy. Or sorry, yeah, remainder or decimal places, we can just consider those. But okay, do you want to code that out? I mean, we can try. So there needs to be logic for the whole this thing multiplying. Let's do that. Let's remove you. Okay. Mm, we will be doing the encoding. So for this, it will be taking two numbers. Um, let's say A, that should be integer, and B, that should be an integer. Okay. And it will return. So A will be the first number, and B will be the second number. So what we'll do is A into 1000 and plus B. Okay. And similarly, we will have decode. So it will take just a simple single number A, and it will return, or let's say that number is C, and we will need to do some operation is need, can I get a pen? So let's say if we are doing, let's say 142 and लेकिन ये 1000 तक जा सकता है राइट और लेस देन इक्वल टू है so means this is not allowed but this is allowed. Hmm. That would create an issue, right? Actually not. Let's say case one where we have 142 and 322. Okay, so what I'll do, 142 multiply with 1000 and plus 322, so 322. Now what we can do is divide and take it. So 142, so 0.322, should give it like that. I don't remember properly. Let's do that. Let's say A is equals to 142, B is equals to 322, and C is equals to A into 1000 plus B. And I'm just keeping it for simplicity, but it will follow the BODMAS rule. So let's print C, and then what we need is print C by 1000. Okay, let's run that. Right. And what we want is what about this modulo. Um, right. And I think this will also do the same. Right. Good. So we got our A and B from here. So we will return C. This will return the first bit, and this will return the second bit. But the issue is we have, let's say, 1000 here and 322. Then 1000, no, let's say, swap this out, okay? So 322000. Now, if we add it, this will change. So we don't want that. So we need to increase it by 10. I don't know if this fits in or not. Okay. Okay, so we got encoding and decoding. Now what we need to do is we will go through the array 1, 2, 3, 4, 4, 3, 2, 1. So we'll go through the array from I and J. Okay, and we will do the encoding and save it in J. Okay, so for I in range N, so which is the middle of it, and this will be our I value, and this will be our J value. Okay, and what we need to do is we need to encode this, and we will be saving it in nums itself at the location of I plus n. Right. So once that's done, it will keep all of the values in I. Oh, sorry, in J. So what we need to do is then decode it. So for let's say ITR in range, this time let's take 2n. All right. N ही रखते हैं. We need to iterate n times only. Um, we need to take out this value and put it in the. So basically, we will take nums of j. We are decoding it or decode. That will give us two values, and we'll put it in nums of I and in nums of, sorry, not I, but ITR and nums of ITR plus 1. Um, so, okay, this is ITR plus N, LJ. And the issue is if we are going ITR wise, so it will point here. And if I'm putting this, then that's a problem because the next number needs to be here. So the range needs to be 2n. कहाँ गया? हाँ. And so instead of doing that, we can use while loop. While ITR is less than equal to 9, less than 2 to the power n, oh sorry, 2 into n, and we put ITR value here equals to 0. Okay, so 0 plus 1, and here we move it by 2. So that should be good. Here obviously I would like to print nums, and after this also I would like to print nums, and we would be returning nums. Okay, let's run this. Uh-huh. So what we got here is um 2003. Okay. So I'm just going one by one. We can go to the error later. So if our encoding works fine or not. So we went here. So 2 and 3 were there. So we got that should be 4. This is 4. 4. That's going 2003. Um, yeah. Mm, what we did here is nums 251 कैसे आ गया? Uh, oh, oh, oh. Yeah. That should do. Really? Still, idea should be less than what? This is 2n minus 1, minus 2. Yeah, right. Not minus 2, minus. Um, while loop are tricky. 2 to the power n. Okay, so that is um, this index, and minus 1 is this. So this should cover ITR and ITR plus 1. ITR if is here, that would be 2n minus 2. So that should cover, right? What's wrong? Minus 1 is this, plus 1 is this, and here is less than this. Okay, what is wrong here? 2n minus 1, this is the position, this is 2n minus 2. Okay, so 2n minus 2 is the number जहाँ पे allowed है. Right. I don't know. Maybe it's not falling through, dude. It's not. Mm, so ITR is less than 2 to the power n, and ITR plus 1 should be less than the power of, sorry, 2n minus 1. क्या कर रहा हूँ मैं? Mm, let me clarify that here. 1, 2, 3, 4, 4, 3, 2, 1. Okay, so this is ITR and this is ITR plus 1, and we are incrementing. Why we are taking these? I mean, just use ing here now. It would make your life much more simpler. And j is equals to I plus 1. and this will be I, and this will be J, and I is less than two to the power n, sorry, 2 times n. So this is n, this is 2n. Okay, and J is less than 2n. Yeah, I don't know. Okay, so what we are getting is no decoding is being done. Uh, what is going on? I know it is not. I don't know. But I did the sorry, AND operation. Yes. And we need to increment I, obviously. And mm-hmm, 952. Yeah. Okay. Let's clear this out. And do it like this. For J in range of n. Cool. So we are considering this as J. Okay. Okay. Um. Shit. N to n. That should be good, right? Um. So we will take will decode nums of J and put it in nums of I and nums of I plus 1. So, and I is equals to I plus 2. Okay, so this will give this. This will give this. This will give this, and this will give this. Uh, should be fine. Let's see. Right. Alrighty. Um, but I am not sure of how much it will work on all of the test cases that they have done. So let's see. Cool. It got passed. Let's go to another one. How much time it took me? I think more than half an hour. But we got the best possible answer there was. So we reduced the time complexity to O of 1. Okay, max consecutive ones. So given in binary array, return the maximum number of consecutive ones in the array. Okay, so 1, 2, 3. So 3 is the answer. That's a simple one, not an issue. So basically what we need to do is we have nums and it's one, like we need to count consecutive ones. So we can have a flag of what's the maximum numbers we have, and we will be iterating through this and counting. If it's one, we'll just add it. Okay, so we will have max and current max. Okay, or instead of current max, just have current sum. All right, and what we'll do, we'll till iterator reach 0, we'll just add the values and then reset it again and then start counting again. Okay, so this is 3, this is 2, and this is 2. So obviously we'll be updating max for each of the cases once we reach a 0 value. Okay, let's do this. We'll code it directly, not an issue. Um, we will need a max value, which could, oh, sorry, max sum, which will be 0. So max is actually a function, so we can't use that as a variable name, and we will use our current sum. Okay, so for I in range of length of nums, we will be iterating through that. And if nums of I is equals to 0, what we need to do is we need to check um, if or we can just do max sum is equals to max of max sum and the current sum, and then we set the current sum to be 0. Okay, else what we need to do is we will just add current sum is equals to current sum plus 1. So I'm hoping that's all of the numbers will be ones. So binary array, so ones and zeros. So that should do fine. And then we will just return max sum. Okay, let's go. Really? Output is to, oh, yeah. So we never got the chance to check it after here. So, mm, we can put it here because then the current sum will be there, right? Okay, cool. Let's submit it. Cool. Yeah, thank you. But I think, yeah, that was mostly it. We will do that match again sometime later. How to go open the quest. Yeah, so we review. Why is it in red? Do I completed? Okay, one of 35. I don't know. Anyways, we completed the array one today. We will be doing the array two tomorrow. So yeah, I think our timing will be something around this, but I'll confirm it tomorrow. Thanks for watching. See you on the day two. Bye.